Hello everyone, in this video we're going to learn about transformation of linear functions. So we have three different types of transformation. The first one is translation. Translation, which means we're going to move the graph up or down, right or left. We have the vertex formula f of s minus h plus k. And we have the parent function of the linear function is f of s equals s. Now, if the value of h right here positive, the graph move to the right h units. If the value of h less than 0, the graph moves to the left absolute value of h units. Alright, the value of k right here positive, the graph moves up k units. The value of k less than 0, the graph moves down absolute value of k units. Alright, so let's take a look at example. Alright, so we have the parent function f of s equals s. Now, g of s equals parenthesis s minus 3 plus 2. Alright, so we see that the vertex right here, so I just write the vertex form. So it could be the vertex form could be f of s minus h plus k. Now I'm gonna match them up. Alright, so I have h right here is gonna be equals 3. Alright, h equals 3. H is not negative 3. A lot of students make mistake. So keep that in mind. If you see the negative side right here, you need to switch the sign. Okay? H becomes positive if you see the negative side right here. H becomes negative if you see the plus side right here. H equals 3 greater than 0. The graph moves to the right 3 units. Now next one, k equals 2. Greater than 0, the graph moves up 2 units. Alright, so we're going to use that mode to check. Alright, the parent function y equals s. Now the new function s can be s minus 3. Alright, you see that? From the blue to the green, the graph moves to the right 3 units, which is s minus 3. Now if I add 2 to see what happens. Alright, so I start from s minus 3 from the green one. And then I'm going to add 2. And the graph moves up 2 units to get the purple one. Alright. Now finally, you're going to compare the blue and the purple only. So this is actually the blue moves to the right 1 unit to get the purple. Or move down 1 unit to get the purple. Why? We look at this one, we just simplify this one, we will see it. It's actually right here. S minus 3 plus 2, which means S minus 1. So the formula f of s minus h like this, and then h equals 1, which is the graph move to the right 1 unit. But if you think about this formula f of s plus k, there is no h, and then k equals negative 1. So the graph moves down 1 unit. Alright, now we're going to take a look at another example. So let's see, I have f of s equals s. This is the parent functions. Now I have g of s equals s plus 3 minus 2. Alright, so in this situation, I use the vertex form. It will be f of s minus h plus k right here. Now you see that the formula, we have the subtraction sign right here, but the function right here does not have the subtraction sign. So we need to find a way to get the subtraction sign right here. So I just rewrite this one as s minus, because I need subtraction sign right here. So because I have plus 3 right here, which means I subtract 3 right here. So because two negative signs next to each other turns out to be positive. So by writing like this, it doesn't change at all. And then minus 2. Alright, so I just rewrite the formula. Vertex formula form right here. So f of s minus h plus k. Now in this situation, you see that h equals negative 3. Alright, h equals negative 3, the graph moves to the left 3 units. Alright, k equals negative 2, the graph moves down 2 units. Right? In other words, you can simplify this one. So if you simplify this one, it's going to be right here. So it turns out to be s plus 3 minus 2 equivalent to s plus 1. Alright? S plus 1, which means the graph f shift to the left 1 unit to get the graph g of s. Or the graph f shift up 1 unit to get the graph g of s. Alright? You can use decimals to check this case. Now, let's move on to the second one. That's the reflection. Now, we have the function f of s. If we talk about s value only, and then s is called input. But if we talk about the whole thing right here, f of s, and then this is called output. Alright, so if you multiply the input by negative 1, the graph reflects over the y-axis. If you multiply the output by negative 1, the graph reflects over the x-axis. Alright, so let's take a look at the example. I have the parent function right here. Alright, so if I put parentheses like this, I multiply s by negative 1, so it turns out to be negative s. And you see that the graph reflects over the y-axis. Now, if I don't put parentheses, I just have the negative s like this, and then it becomes the red line right here, and the graph reflects over the x-axis. Now, let's move on to the last one, dilation. You need to pay attention to the number inside or outside parentheses. So look at this function right here. If you multiply the input by a number from 0 to 1, you will get the new graph, which is horizontally stretched, or more horizontal, or less steep, or flatter. Now let's take a look at the example. I have the parent function y equals s. Now I have the new function 1/3 s. And you see the green one more horizontal or horizontal stretch. Alright, the next one. If you multiply the input by a number greater than 1, you will get the new graph that is horizontally compressed, or more vertical, or steeper. Now, look at the next one. So I'm going to multiply the parent function by 3. So I have parentheses 3s. So you see that the purple one is going to be steeper. Now, next one. If you multiply the output by a number greater than 1, you will get the new graph, which is vertically stretched or more vertical or steeper or less flat. So let's see. You will get this. You will get the same thing as this guy right here. Alright, so you just don't put parentheses. You just have 3s. Right, you see that the purple one and the black one right here overlapping. And the last one, if you multiply the output by a number from 0 to 1, the new graph should be vertically compressed or more horizontal or less steep. Alright, so you will get the graph right here, the green one right here. Alright, so let's see. I don't put parentheses. I have 1/3 times s. You see that the green one and the red one overlapping. Now, because the parent function is f of s equal s, but if you have another function that has the y-intercept different from 0, and then you will see the difference between this guy and this guy, this guy and this guy right here. Alright, so let's go to the practice. Right here. Now identify the 3 types of transformation. So we have translation, reflection, and dilation. Now what is the difference between a slope change and a translation? Slope change will make the graph steeper or less steep. Translation just moves the graph up, down, right, or left. Now describe the transformation that maps f of s to g of s. So this is very simple. We just this example in the note. Alright, let's take a look at number 5 right here. F of s equals 2x minus 3. G of s equals 6 times 2x minus 3 is the same thing as 6 times f of s, because f of s equals 2x minus 3. Alright, so you just multiply the output by the number greater than 1. And you just learn in the note that when you multiply the output by a number greater than 1, you will get the new graph that is more vertical or vertical stretch. Alright, so let's use Desmos to check our work. So I have the old function 2x minus 3. I have the new function 6 times 2x minus 3. And you see that the purple one is the new one, which is vertically stretched or more vertical. Alright, now number 6 right here is very simple. G of s equals 10s plus 4. I can rewrite this one as 10s plus 1 plus 3. Alright, because 10s plus 1 right here equals f of s, so I just replace with f of s plus 3. So the new function g of s is a result of a translation of the function f of s up by 3 units. Alright, next one. This one is very good example for you to practice. Question 7 and question 8. Question 9 and question 10. Question 11 and question 12. Question 13 and 14. Alright, now question 15. A car rental store rents cars for $20 a day. The function f of s equals 20s. Right, so I just write f of s right here equals 20s. Alright, the company decided to add a one-time $10 fee for cleaning. Write the function at g of s. So you just have 3 of g of s equals 20s plus 10. Alright, and you just rewrite this one. Replace 20s with f of s because f of s equals 20s. So it will be f of s right here plus 10. Alright, now how would the graph of GFS compared to the graph of FFS. So the graph GFS is a result of a translation of the function FFS up by 10 units. And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.